Students, I hope all of you will be fine. In today's lesson, we will prove that under 2 is an irrational number. We will follow the method of contradiction here. The method of contradiction says that if we want to prove something, we will suppose its reverse. For example, here we need to prove that under 2 is an irrational number, but in contradiction method we will suppose that under 2 is a rational number. And when we will start our proof by this supposition, by this wrong supposition, then somewhere in our proof there will come any fault or any problem. And to explain that problem, we will be able to say that our supposition was not correct, our supposition was wrong, and then we will say that under root 2 is not rational, but it is rational number. In this way our proof will be complete. So let us start how to prove this one. We will suppose that under root 2 is rational, which is converse of our statement. And it is in lowest form. The meaning of lowest form is that, for example, if I write 10 over 6, then 10 over 6 is not in lowest form. I can further reduce it to 5 over 3 by dividing both number by 2. So now 5 over 3 is in reduced form, but 10 over 6 is not in reduced form. Now I will write that as under 2 is rational, so I can write that under root 2 is written in the form of p over q. Now I will take square on both sides. P square over q square equal to 2. Now if I divide q square on both sides, then p square will become equal to 2q square. Now p square is equal to 2q square. Here we can see that right hand side is the multiple of 2. So left hand side should be also multiple of 2. It means that in place of p there should be a number that is multiple of 2. So I can write p is equal to 2p prime. Now if p is equal to 2p prime, then I can put the value of p, which is 2p prime, in this equation, and it is followed by a square, so I will take a square, then it is equal to 2q square. This equation I will give name star. Now I will open the square and it will become 4p prime square, which is equal to 2q square. Now if I divide 2 on both sides, it will become 2p prime square equal to q square. Again we can see that left hand side is multiple of 2, so right hand side should be also multiple of 2. It means that q should be a multiple of 2 and it should be written as 2q prime because it is also multiple of 2. Now this is double static. Now we said that p over q is in simplest form, but p is equal to 2p prime and q is equal to 2q prime. Here we can see that p over q is equal to 2p prime over 2q prime, and both are not in simplest form, they can be reduced by 2, but our supposition was that they were in simplest form, they are in simplest form, but here we can see that they are not in simplest form, they can be divided by 2, which is contradiction, and hence we can write under root 2 is an irrational, because our supposition was wrong. In this way, we can prove, by following this step, we can prove any number which is irrational. We can prove that it is really irrational. Also, we know that irrational numbers are non-terminating and non-recurring, but that is not the method in the form of proof. The proof will follow these methods. Now, for example, if we take a number 11, under root 11 is irrational, and we want to prove, so we will follow the same step as we followed in above mentioned method. We will consider that under root 2 is rational and it is in simplest form. Then we can write under root 11 is equal to p over q, squaring on both sides, and after squaring it will become p square over q square. Now q square will be multiplied on left side, it will become 11q square equal to p square. Now left hand side is multiple of 11, so right hand side should be also multiple of 11. It means that p should be equal to 11p prime, because it should be also multiple of 11. And this is equation static. If I put value of p in here, then it will become, this equation will become 11q square equal to 11p prime whole square. 11q square is equal to 11 square will become 121 and p prime square. Now I can divide both sides by 11. Q square will become 11 11s are 121 p prime square. Now again right hand side is multiple of 11, so left hand side should be also multiple of 11. So it means that q should be equal to 11 q prime. This is our double star. Now p over q was in simplest form, but here p from static p is 11p prime and q is also 11q prime. We can see that they are not in simplest form, they can still reduce by 11, which is contradiction, and hence it proves that under root 11 is irrational. So this was the proof of our given topic. I hope that you will understand. If you like the video, please subscribe and like it. Thank you.